Hey Golden Ones, it is I, the Kobold. Last week we learned how to create a monogame project, figured out our target resolution, and learned how to draw our tennis court. This week we are going to improve on that by learning about game state and implementing the ball and paddles. After today's tutorial, you will have a game of Pong playing between two AI. First up is the question, how will we handle game state? The answer is implementing a rudimentary state machine. A state machine is a behavior model that consists of a number of states. Unity, for example, uses a finite state machine to handle their animation system. The simplest state machine that we can create is just using a simple switch statement. A switch statement takes a variable and uses pattern matching to branch to each pattern's code. In our case, we are going to use an enumeration type as our variable. An enumeration type is a value type defined by a set of named constants of underlying integral numeric type. So we can name our states in an enumeration type and use a switch statement to only write code for that state. So let's start implementing that. Let's brainstorm what states our game might need. Go ahead and pause this video and think about how you would break up your game into different logical components. I'll still be here when you're done. You done? Good. Let's see how close you are to what I came up with. First of all, we need an idle state. In my idle state, the game is waiting for a game to start. In the arcade, this would be considered an attract mode. The original Atari Pong had a screen where the ball would just bounce about the screen while it wasn't being played. So we're going to copy that. Basically, my idle state will have a ball bouncing around the screen while waiting for input. Once input is pressed, we are going to move on to our next state. Our next state is the start state. Its purpose is to get the game ready to play. During this state, we'll reset scores, reset paddles to the center of the screen, and set up serving the ball. Essentially, it'll do all that, then change the state to the next one. We'll only ever be in this state for a single frame. After the start state, we've got the play state. We move the ball, control the paddles, and check for collisions during this state. If a scoring event happens, we will iterate to our next state. This will handle most of our active gameplay. From the play state, we change to the check-in state. In it, we check if the score reaches a winnable threshold, and if it does, we change back to the idle state. If it did not reach that threshold, we set up serving the ball and go back to the play state. As you can see from my state diagram, it is a pretty simple game flow. The main thing is we separate the game logic by state instead of checking these things every update loop. It makes the code much more manageable. Take the time before you start any project and think how your game state will flow. It will save you a lot of hassle later on as you develop it. Now that we've defined our states, let's get started by implementing the skeleton in our game code. So first off, we define our enumeration type and our field storing our state enumeration type. We'll use this field to keep the state between updates. Next up, in the constructor, we assign the idle state to our state field so that the game starts in the idle state. Then, we add our state machine to our update method. Right now, I've got the states cycling through themselves, ending up on the play state. Make note that you have to call break at the end of each state's case. Finally, we add the state machine to the draw method. Our states will draw differently, so we'll have to have them appear in the draw. Do you notice how there is no break between the play state and the check-in state? As long as you have no statement in your case, you can have it fall through to another. It basically tells the compiler that they are treated the same. We do this in the check-in state and the play state because they will be drawn exactly alike. There we have it. We have made our skeleton for our state machine. Not so hard, eh? Don't worry, I'm just pausing the video here to thank you for joining me today. This channel is in its infancy, and if you liked what you've seen so far, make sure to leave a like and subscribe if you haven't already. I post content related to games and development, and would certainly like you to join me in the future. Alright, let's get back to the video. With the state figured out, we have a framework for our game, but no game. To have a paddle and ball game, we need to develop the paddles and the ball. Let's start by developing our ball first, as our idle state only needs the ball. So what is our ball in logical terms? Well, it's going to be an object that has a position, a velocity, and a bounding box. Every frame, the velocity will be applied to the position, giving us a new position. We'll have to check to make sure it stays within the bounds of the screen, reversing its velocity in that dimension if it crosses the border. So, with that in mind, let's start implementing it. We go ahead and set up 4 fields. The first 2 basically define our ball. The rectangle defines the ball's position, drawing, and its bounding box. The point defines its velocity. Point in Monogame holds an x and y value in integer form. Usually, you'd use a vector 2 for velocity, which stores the values as floats, but I don't plan on having any non-integer values. The boolean is used to determine which side scored last. We store this for serving purposes. True means the left side scored, so we will serve it to the right, while false means the right side scored, and we'll serve it to the left. Finally, the random object will be what we use to determine the random values. We will only use random values when serving the ball to keep the game interesting. In the constructor, we just create the random object so that we can use it. In initialize, we call the reset ball method. The reset ball method sets the ball's position to the center of the screen and sets its velocity based on the serving boolean before and some random numbers. The direction is based on the boolean, while the actual velocity is random. We have a new operator here called a conditional operator. It's used like an if statement, but used just for expressions. Basically, you put forth a conditional expression, use the conditional operator, and if it's true, it'll be the value after the question mark, while if it's false, it will use the value after the colon. This way, you can do a conditional value without using multiple lines. Now we have the move ball method. This method will be called by the update method to apply the ball's velocity and handle collisions with walls. It takes one parameter, a boolean. This boolean tells whether it should bounce off the side of the walls or count it as a score. If we call it with true, like we would with the idle state, it will bounce. If we call it with false, like we would with the play state, it will count as a score. Let's run through it. First, we add the velocity axes to the position axes. Next, we check each side for collision. First the top and bottom, which will always bounce. Remember, 0 is the top and 480 is the bottom, while the ball's position will actually be its top left corner. If you cross the border of either of them, we put the ball back on the screen and we reverse the velocity. For the bottom, we also track the height of the ball, as that will be what is interacting with the bottom. We then do the same for the left and right side, though now we check if it can bounce. If we can't bounce, it returns -1 if the right side scored, or 1 if the left side scored. Finally, if we haven't already returned, it returns 0, saying no one scored. Now, we can add this to the game's update. Add a call to the move ball method to the idle state. Make sure to set the parameter to true so that it bounces off all sides. We will go ahead and comment out the change in states so that after we are done with our changes, you can go test the code. In the start state, go ahead and add a call to reset ball. This will get the game ready to play. In the play state, we call the move ball method and store its return value. We take that return value and check if one side scored. If they scored, we set the scoring side and change the state to check end. Finally, in the check end case, we call reset ball, so that the game will reserve the ball and continue playing forever. The last thing we need to do before we can test is to draw the ball. So we add a sprite batch draw to both the idle case and the play check-in cases. Normally, instead of doubling up code, we create a method just for it, but this is one line, so whatever. Go ahead and compile and run it. The game should look like this with the ball bouncing around the screen. If it does not, make sure you commented out the state change in the idle case of the update method. Got the same results? Good. Let's add the paddles. What do we need to handle each paddle? My solution is you only really need a position and a bounding box. So all we need is a rectangle for each paddle. Input and artificial intelligence will dictate where the paddle moves, so we don't need a value storing velocity like the ball. So let's implement it. Like always, we'll define our fields first. we will declare an array of rectangles. We won't define them in the constructor because I don't need them to have a value till the start state. Now, we need a way to move them. So since I haven't taught you about input, we'll go ahead and implement a simple AI. Here is our AI paddle move method. It takes an integer index as a parameter, which defines which paddle it is moving. In it, we see how far along the y-axis the center of the paddle is from the center of the ball. We then apply this difference to the paddle's position. In this way, it perfectly tracks the ball. If you want to lower the difficulty of the game, you can create a cap for how much the paddle moves. This is something you can try to implement yourself as an exercise. Now that the paddles have a method for movement, we need some implementation for collision detection. Here's a method that just tests if a paddle and the ball overlaps. This type of collision detection is called Axis Aligned Bounding Boxes, or AABB for short. Axis aligned bounding boxes work anytime you have two boxes that share the same two axes. Any rotation and it doesn't work. In our case, it works. It tests if the paddle's left side is to the left of the ball's right side, while its right side is to the right of the ball's left, while its top is above the ball's bottom, and while its bottom is below the ball's top. If all four of these statements are true, your rectangles overlap. Interestingly, the rectangle class has a method to do this for you, so you can actually write it like this. If you were to use this test for collisions by itself, you would have a bad time. After the ball picks up enough velocity, it could go right through the paddle, and this check wouldn't catch it as its end position would be outside the paddle. So, let's rewrite this method so it checks an x and y value that we provide it later based on where we think the ball could have been when it was hit. So now we take an x and y coordinate and do the check using those. Now, we got to do the math figuring out where the ball may have been when it collided with each paddle. I call this method paddle ball check. We declare two variables that we'll be using across this method. Delta is going to store the distance between the paddle and the ball on the x-axis, while the pad stores which paddle was possibly hit. We check the direction the ball is going, and if it passed the paddle on that side. If it did, we may have had a collision. If not, we return false, meaning there was no collision. So to check, we calculate the delta of the x-coordinate. If it's moved further than the ball's velocity, we return false because it's already passed the paddle in a previous frame. If it's smaller than its velocity, we set the pad to the index of that paddle it might have hit. So now that we know that the ball may have hit a paddle, we figure out the percentage of velocity that the ball has moved past the paddle. We then get and store the coordinates of the ball after removing that percentage of velocity from its current position. This is where the ball may have hit the paddle. Now we can use our collection check from before. If there's a collision, we can reverse the ball's x velocity, increasing the velocity by 1, and set its position to our collision position. There's one more thing we need to implement in this method, and that is the English. We now need to figure out the difference in the center of the ball and the center of the paddle's y position. We divide that value by 1/8 of the paddle's height. This will give us a value between -4 and 4, which we are going to subtract the sign from to make it a value between -3 and 3 with a bigger 0 range. We add this to the ball's y velocity. Finally, we return true saying a collision happened, and we return false outside of it to show it didn't happen. We now know that the paddles will collide with the ball, and the ball will react to being hit. Let's finish implementing that. In the update method, let's define the paddle array in the start case. In the play case, we add our two paddles move calls and call our paddle ball check. While you are looking at this code, don't forget to remove the comment from the state change in the idle state. Our game should run now, but you need to draw the paddles before compiling or you won't see them. In the draw method, add these two draws to the play and check-in state. Go ahead and compile and run it. If you got two AI locked in an infinite game of Pong, you're good. That's what's supposed to happen. If the ball is bouncing around the screen with no paddles, You probably forgot to remove the commenting from the change to the start state from the idle state. As an exercise, see what you can do to make the AI lose. I mentioned one method in the Pong history video, so maybe you should go back and watch that if you need inspiration. This is a good exercise in both programming skill and game design skill. Next week, we will refactor the code where the ball and pedals are encapsulated in their own classes. We'll add basic player input, learn about the content pipeline, and add scoring and sound. It sounds like a lot, but after next week, this will be a pretty good implementation of Pong. Did you learn anything this week? Were you able to nerf the AI just enough to keep it interesting? Tell me your experience down below. And as always, stay gold, code bold, and farewell from the Code Bold.